Assalamu alaikum. I'm Mohammad Ishatul Haq, and I'm going to describe the remaining two parts of neural networks and neural language models. The parts are training neural network and neural language models. So I'm going to talk about first training neural networks. So training network means training a neural network, and it involves using an optimization algorithm to find a set of words to best map inputs to outputs. The problem is hard, not least because the error surface is highly multidimensional, non-convex, and contains local minima, flat spots. So to training a neural nets, execution of several methods has to be done. So we're going to talk about first loss function. Loss function is a method that tells us how good our neural network is for a certain task, and it has two parts: cross entropy loss and negative log likelihood loss. Cross entropy is a measure from the field of information theory, building upon entropy and generally calculating the difference between two probability distribution. Log likelihood value is a measure of goodness of fit for any model, and we use negative log likelihood as minimizing that is equivalent to maximizing the log likelihood, or like or the likelihood itself. Doing a log transform converts these small numbers to large number negative values which a finite precision machine can handle better. And after that, computational graph. A computational graph is defined as a directed graph where the nodes correspond to mathematical operation. Computational graphs are a way of expressing and evaluating a mathematical expression. Training a neural network involves differentiation on computation graphs in the backward direction. After that, gradient descent. Gradient descent is a first order iterative optimization algorithm for finding a local minimum of a differentiable function, and it involves in two parts: softmax loss problem and backpropagation. Softmax is an activation function that outputs the probability for each class, and these probabilities will sum up to 1. And softmax loss is actually just a softmax activation plus a cross entropy loss. And artificial neural networks use backpropagation as a learning algorithm to compute a gradient descent with respect to weights. Now I'm going to talk about the last part, neural language models. A neural network language model is a language model based on neural networks, exploiting their ability to learn distributed. The goal of language modeling is to estimate the probability distribution of various linguistic units: words, sentences, etc. It has two parts: feed-forward and embedding. The feed-forward neural network was the first and simplest type of artificial neural network devised. In this network, the information moves in the only one direction, forward from the input nodes through the hidden nodes and to the output nodes. There are no cycles or loops in this network. In the context of machine learning, an embedding is a low-dimensional, learned continuous vector representation of discrete variables into which one can translate high-dimensional vectors. So generally, embeddings make ML models more efficient and more easier to work with, and can be used with other models as well. For example, pre-trained model. The concept of pre-training is inspired by human beings. A pre-trained model is a model that has been created by someone else to solve a similar problem. Instead of building a model from scratch to solve a similar problem, you can use the model trained on other problem as a starting point. For example, if you want to build a self-learning car, a pre-trained model is a model that has been created by someone else to solve a similar problem. Instead of building a model from scratch to solve a similar problem, you can use the model trained on other problem as a starting point. For example, if you want to build a self-learning car. So that was all from the neural networks and neural language models. Thank you.